I want to show you the new ways you can extend Buckaroo with a 0.6 release. Buckaroo is built for exploratory data analysis on unknown data. Data in the wild is incredibly varied, and so are the ways of visualizing it. Most table tools are built around allowing a single bespoke customization with middle-of-the-road defaults. Buckaroo takes a different approach. Buckaroo lets you build many highly specific configurations and toggle between them quickly. This makes it easier to build each configuration because you don't have to solve for every possibility. This document walks you through how to add your own analysis to Buckaroo and allow users to toggle and cycle through it. The extension points are the pluggable analysis framework, which allows adding new summary stats, styling to control the visual display of the table, post-processing, which is used to transform an entire data frame, and auto-cleaning to automate pre-processing transformations. Let's get started. So we're going to import some Python boilerplate, Buckaroo boilerplate, create a data frame with 3 columns, 4, int column, float column, timestamp, and string column. This is what it looks like in Buckaroo by default. And we have summary stats, and that's pretty good. Let's add another stat with the pluggable analysis framework. There are additional links in this to the unit tests, which demonstrate how to use all the aspects of the pluggable analysis framework, and the default polars analysis. Pluggable analysis framework runs on each data frame, and it constructs a dictionary of metadata about each column. This can be used by other pieces in the pluggable analysis framework. And the pluggable analysis framework organizes all of this. So let's do something simple where we're just going to add the 99th quintile measure and display this in Buckaroo. So we have a select clauses and quintile 99, some words, and we display this. Okay, this does not show up until we toggle over to the summary view. When I cycle through these, you just click and you get the next data frame displayed. I could make this a drop down. I find it quicker to click through. I probably will make it a drop down in a subsequent release. So here are the quintiles. Nice. Let's add some styling. Styling analysis lets you control the display of columns based on their metadata. So we're going to add 2 stylings. We're going to add an everything analysis, which displays long form versions of columns with long strings and many decimal points. We're going to depend on is numeric, D type, and type. And we have a style method where you basically switch on type and you return a different displayer. And then we have abbrev, which gives a different styler for date times. We have created these classes, and then we have an instance of Buckaroo, add analysis, add analysis. So that's the standard look. This is everything. So look how long the float columns are. And then there's abbreviated, and you're actually chopping off a little bit of string column, and timestamps are abbreviated. The full styling gallery is here. In the styling gallery, I've gone through this in other videos, but you can look at this data frame and execute it. And you can see all the different styles that you can apply to a column with Buckaroo. Let's add a post-processing method. So the first thing we're going to do is we're going to add a transpose method. This takes all the rows and makes them columns, and the columns and makes them rows. To do this, we instantiate Buckaroo on our data frame, and we just call the add processing decorator. And here's our function. We just get a data frame, and we turn df.transpose, and then we display the Buckaroo widget. And we're defaulting to the transpose view. So now we can see we have 200 columns and 4 rows. And then we can turn that off. So you can toggle between this view and the regular view. Let's create our own widget with built-in analyses. So we're going to have the value count analysis, which takes, it's another post-processing method. It takes the top 10 most popular values, prefixes the column name with val underscore, and count, takes the counts and prefixes it with count underscore. And we call this value counts. And then show errors post-processing. So this says we're going to say every row where the float col is less than 20 is an error. And we add an extra column called errored float, which will have a value of some error when float col is less than 20. And then we add a column config override, which will color the proper float col cells. Add a tooltip, which refers to the errored float value, and we hide the errored float column. Then we put this all into a Buckaroo widget, and then we have this VC Buckaroo widget that you can instantiate whenever you want. And it just says, here's this analysis all packaged. Let's execute this. Standard look. Value count, val int count, count int col. Val int col, count int col. Val float col, count float col. Sort by this. Be nice if there was count, float col count, but whatever, that was the way I built it. You can edit it as you want. Here's show errors. So 12 less than 20 gets read, and we say some error. Some error, some error. Where to use post-processing? Post-processing functions are no argument transformations. I can't think of a lot of generic whole data frame operations, but I can think of some. Value count and transpose are generic. Show errors depends on two specific columns. I expect post-processing to be very useful for small custom apps built on top of Buckaroo. When you know the columns and you want a strict set of transforms, post-processing is a great fit. Post-processing is also used when combined with a pre-processing function to compare data frames. Here is some pseudocode. So say we want a compare function that displays comparisons of data frames in some way. Compare takes df1 and df2, and then you prefix every column name with df1 pipe and df2 pipe, and you call the compare widget. In the compare widget, in the post-processing method, you split the columns on pipe, you run your comparison, so you could say, what's the difference between each row of each column? What's the percentage difference? You could put in histograms, you could put in charts. There's a lot that you could do. You could do statistical measures. And then when you wanted to use this, you would just call compare sales March 2022, sales March 2023. Now we're going to make a kitchen sink widget. We've created 4 analyses in this demonstration, and we have value count, Quin99, value count post-processing, show errors post-processing, everything styling, and abbrev styling. We also have put in all the basic existing analysis functions. And then let's execute this. So now we can toggle between our different analyses. We can also toggle between our different styling of these analyses. So here's everything, and there's the abbreviation. Styling is orthogonal to post-processing, and you can use that to do all kinds of stuff. Why aren't there click handlers? Buckaroo doesn't allow arbitrary click handlers, and this is by design. When you allow arbitrary click handlers, you then have to manage state. If you have noticed, every method of extending Buckaroo is a pure function. Managing application state is difficult and the primary source of errors when building GUIs. Buckaroo is designed purely around displaying data frames, along with the most common operations that are performed on data frames. If you want to build more traditional app experiences, right now you can use IPy widgets and integrate Buckaroo into it. Soon, I will be releasing the DF viewer, the core component of the data frame that shows for the table, for Streamlit and Solera. What about the auto cleaning and low code UI? Auto cleaning and the low code UI work together to allow for more fine-grained editing of data. The low code UI presents a GUI that works on columns and allows functions with arguments. Auto cleaning works to suggest operations that are loaded into the low code UI. These operations can be edited or removed. Auto cleaning options can be cycled through to generate different cleanings. And I'm going to show you this in a previous version of Buckaroo. So here's our city bike data, and here is the low code UI. I'm going to click on start station name, and we're going to group by that column. And we see these are extra arguments being sent to start station. We're going to take the mean of trip duration. Now we see down here in the transform data frame, we have the mean here, and then we'll just take the count of this one. So we can see there were 63 trips to First Avenue and East 15th Street. Yeah, East 15th, East 18th. And they had an average duration of 641 seconds. This is what auto cleaning looks like. So auto cleaning works with the low code UI to populate the low code UI. And one of the interesting things we did is we changed gender here and we called toInt, because I know the original data has, here we'll just sort by this, gender, or yeah. I think it was gender. Anyway, you can now also view the Python code for all of this, and you can remove different functions. The auto cleaning UI is not in this release. We have a limited amount of time, and it wasn't seeing a lot of adoption. I will get back to it at some point, but I really want to focus on adding Buckaroo to Streamlit and Solera at this point. When the auto cleaning UI is enabled for 0.6, you will also be able to cycle through different auto cleaning configurations, and that is orthogonal to summary stats, to styling, and post-processing. So you can use auto cleaning to get the data in the best shape and then call post-processing on it. This is once again a preview of 0.6. There's just a little more cleanup to do, but thank you for your time listening to this.